to do much better. The combination of this research with modern information technology is setting the stage for a new, more effective approach to science education based on the tools of science. What Carl says is, you wouldn't dream of doing your physics without scientific methodologies, and yet you dream of teaching without employing scientific methodologies when you teach. And we need to use ICT differently than we are now. We need to use ICT to enable local, national, and international teams, and thank you again for a new term, Jim, of transdisciplinary experts to create scientifically designed, interactive, adaptive, continuously assessing, this is a lot, networked virtual learning environments to replace textbooks. I'll show you an example in a minute. And we need to build a network of experts that are developing and using these virtual learning environments throughout the world to continuously research their effectiveness and continuously improve them so we get better. I'll give you one example, a project we worked on at Carnegie Mellon with many people from around the world. The project is called the Open Learning Initiative. It was started in Carnegie Mellon in 2003. The design is what we're trying to do is to provide the complete enactment of instruction in a particular course, in statistics, in biology, in physics, for novice learners in a number of subject areas entirely on the web. You don't have to use them that way. You can use them as a textbook. Indeed, we've learned that using them as a textbook is probably the best way. What are our guiding principles? You've heard them from me already. Make the course design and delivery scientifically informed, continuously improved, and an international team sport with colleagues around the world who are using these courses and helping us to improve them and developing their own and adding to the library of these courses. This is the URL. I have not nearly enough time. Like Fabrizio, I could speak 2 days on the Open Learning Initiative. It excites me as much as anything in the world. I don't have time. I urge you to go there. These courses are freely and openly available to anyone in the world. They are not like MIT's OpenCourseWare. They are designed to instruct novice learners. Therefore, you click around and it may not seem very interesting. But if you actually follow through a lesson all the way through, I think you'll find it very interesting. We now have 11 courses. We'll be adding 2 more very soon. And anyone who is interested in working on developing a course with us, according to these principles, is more than welcome. Let me give you 2 very brief examples of how we use results from the cognitive sciences to design every aspect, almost every aspect of these courses. So these are 2 of many, many examples. The idea here is, how does science drive the design? Here's one example. A fundamental result from cognitive science says students learn much better when they get immediate and targeted feedback. It's Socrates sitting with his pupil. The pupil of Socrates gets immediate and targeted feedback from Socrates. Can we use ICT to do that? Yes, we can. That's going to be our refrain. Yes, we can. Here's an example from an engineering course in which a student is answering questions about vector addition. Okay, don't worry, there will be no exam. Okay? And here's the problem presented, and this is supposed to be a test of whether the student has gotten the idea or not. So I'm going to start this. This is just a movie of the student working on it. And this is a small version of what we call an intelligent tutoring system that is responding to the student, saying whether it's right or not. And it tells the student that they can ask for a hint if they want to. The student asks for a hint. And the tutor says, recall, let me take you through the steps here. We've been through this before, let me take you through the steps. The student can ask for hints as he or she goes along. And the tutor gives the students hints in solving the problem, reminding them of what the student has gone over before, much as the tutor might. Okay? Then it might just bottom out and say, okay, here's the answer. Then if the student still needs more help, they can continue to ask for more help on this problem, which this student has chosen to do. And then eventually, when the student gets to the end, it's not represented in this particular movie, the student is told, now you were supposed to know this. So you have not completed the problem, do you want another problem? And it gives the student another problem. So they get immediate feedback and then a chance to do it again. Here's another example of how we take results from cognitive science, from learning science, and apply it. Cognitive scientists tell us that if you give students not made-up problems, but authentic problems from real-world situations that are like the actual practice of the discipline, they learn much better. So in a chemistry course, we said, okay, chemistry homework tends to be given in the form of simultaneous equations to solve. So the students go home with a textbook, they open the textbook, and they try to solve a set of equations. That's not what chemists do. What chemists do is go into a laboratory, by and large, and solve the problem using chemicals. So we created, especially Dr. David Yaron, who deserves most of the credit for this, a major part of the team, a virtual chemistry laboratory. This is one of the most remarkable pieces of software I've ever seen. There are other virtual chemistry laboratories on the lab, but this one is really good. It's a full stock room there on the left. You can get any chemical you want. You can get any glassware you want. You can bring that out into the workbench. It tells you about the nature of the chemicals you're using. There you got a Bunsen burner, right? And this all works the way it's supposed to in a chemistry lab. Now, let me say what he was changing here. What he was changing here was the fundamental nature of homework. When students get problems in this class, they go home and solve the problems in this virtual chemistry lab. They don't do just math. Math is part of it, but then they also solve the problem the way a chemist would. In addition to that, we embed these lessons in real-world situations, such as the problem of arsenic poisoning in Bangladesh. The wells in Bangladesh are naturally poisoned by arsenic. And so when they're given a problem, they're given an authentic problem to solve, of the kind that you would have to solve if you were a working chemist. So those are just two very quick examples of how we use cognitive science to design what we do. Now I'm getting to what we consider to be the killer application here. What software people call, what's the killer app? The killer app for us is, you remember the race car that was instrumented, the speedometer, the odometer, the oil pressure, everything? We have instrumented these courses to track what all the students are doing very closely, so that this can be used